Subscribe to our YouTube channel, Joy Learning TV.
I welcome you to Senior High School R on the Joy Learning television channel. And Kpabi Albert is my name. You can call me Pius. And I'm going to take you through a practical physics lesson in simple pendulum. In our previous lesson, we were able to look at the question and then the actual experiment. Then we were able to obtain some readings or data for our table. Now, we want to try and complete filling the table. Go ahead and look at how we can tackle the question as we prepare to draw the graph as part of answering the question. So, we had these lengths from the question: 100, 80, 60, 50, and 40. And we were able to get the timings. You repeat the timing for oscillations for each length. So first time, second time, first time, second time, first time, second time, like that. Now, we understood that for the experiment, we have to make sure that there is a trend of values. So a trend of values here means that as you go down the table, are your values increasing or decreasing? In this example, or in this case, you have 40, 36, 31, 28, 26. So as we go down the table, our values are decreasing. That is a trend. It could also happen another time that as we go down the table, the values will be increasing. They're becoming higher and higher in other experiments. That is also a trend. It could also be that usually you have 5 values. The first 2 may be increasing. You get a value in between, and then you have the last 2 decreasing. So the values may be increasing, then they start decreasing. That's also a trend. Probably I'm going to draw a curve. So for a curve which is an upward curve, it rises and falls. So the values may increase, then decrease. It could also happen that the values will be decreasing, then they will start increasing. Another possibility. That could also be a curve, but a downward one. So the values will be decreasing, then they start increasing. So all the time, watch out for a trend in values in the table, or a trend of values in the table. If you don't get the trend, please, the experiment is not right. It's not correct, and you have to go back and take the experiment again. Now, sometimes too, you might have the values decreasing, but one of them somewhere may deviate from the usual course. So assuming 40, 36, 31, then this one, assuming it was, let's say, 35, higher than this, it will mean there's a problem here. So what do? You go back to the experiment and you repeat the experiment for only that length that you think or that has given you a deviation. Then you correct the anomaly. Okay? So if there's any problem somewhere, you try and then you correct it. So we're going to go ahead and fill the table. Now I'm saying that for time t, the question asks you to find a time for 20 oscillations. We found t1 and t2. Pick your calculator. Then we start to add. So I have 40.14 plus 40.50 divided by 2. I have 40.32. I pick the next set. 36.17 plus 36.09. I divide by 2. I have 36.13. 31.33 plus 31.47. I'll divide by 2, and I have 31.37. 28.96 plus 28.55 and divide by 2. And I have 28.75. And now let's note this. I'll write it here. 28.755. In the first case, this is giving me a value with 3 decimal places. 1, 2, 3. Numbers after the decimal place. I have established, I've told you that in a column, all the values in the column should have the same number of decimal places. So here we have to shorten this to 2 decimal places. Now elsewhere, you could say 28.76. Why? Because after this 5, the value here is 5. So we can approximate this to 76. If you write 28.76 in the table, you will not be penalized. No. But from experience, I've realized that if you do approximations in your table, your errors introduced in the work becomes bigger. So, as much as possible, avoid approximations as you put the values in the table. So instead of writing 28.76, I would prefer 28.75. It helps you with your line of best fit, so that the values or the numbers that you plot, when you're supposed to draw a line of best fit, even if some of the values or the points will deviate, they will be at most 2 smaller boxes from the line of best fit, and you'll be getting a mark for that. So I have 28.75. So I will not approximate, and I will not write to more than 2 decimal places, because all the others I have before this one have 2 decimal places, and I want to maintain that. Now I have this 26.02 plus 26.13 divided by 2. I'm getting 26.075. So here too, I'll write it as 26.07 to 2 decimal places, no approximation. So we are through with our time. Now you are asked to find period. Note, in the question it said, find the period T. Nobody will show you how to find the period. Now, in simple harmonic motion, period is defined as the time taken by a body to make one complete oscillation. Let's do rotation and proportion here. Let's pick this one. The time to make 20 oscillations for this length is 40. So our time here is 40.32 for 20 oscillations. The period is the time to make only one oscillation. So I'll say period T is giving me one oscillation. So the question is, if I want T, what do I do? I'll cross multiply. This way, that way. So I'm going to get 20 times T, which will be 20T, equals 40 times 1, or 40.32 times 1. Don't forget that this here represents our small t. So I have 20T, capital T, equals small t. I want capital T, so I'll divide by the coefficient of the capital T, which is 20. So I get T giving me small t on 20. So you see the reason why I've written capital T here is equal to small t on 20. The period is found by dividing the time by the total number of oscillations. Here, the total number of oscillations is 20. I'll divide by 20. If it is 10, I'll divide by 10. So you divide by the total number of oscillations. So, take a calculator and then we do the division. So I have 40.32, I'll divide by 20. I'm getting 2.016. I can choose to start with 2 decimal places. Then in the whole column, I should have 2 decimal places. Or I can choose to use all the 3 decimal places and I'll maintain it through the whole column. 36.13 divided by 20. Now I have 1.8065. This has got 4 decimal places. 1, 2, 3, 4. I'll choose only 3 of them and I will not approximate. I won't say 807. I'll use 806. $31.37 divided by 20. Here again I have 1.5685. So that's 1.568 and not 1.569. I will not approximate. $28.75 divided by 20. I have 1.4375. I write it as 1.437. Like that. And the last one, 26.07 divided by 20. I have 1.3035. That will be written as 1.303. That gives us the period. Then the question says we should find period squared. So whatever we have as our period, we square it. These things are from the question and it's not just constant. You stick to the question and you answer it. So t squared will give me 2.016 squared. So I'll write it to 3 decimal places, 4.064. 4.064. Then I'm going to square this one too. .261636. 3 decimal places. We'll square this one too. I'm having 2.4586 and all that. Then 1.437 squared. I have 2.064. .697. So we have been able to draw our table. We've been able to fill in the table. Now, no cancellations in the table. No cancellation in the table. No deepening or shading of values in the table. The good news is that in WAEC exams, as part of the instructions, students are told that they can present this table in pencil. So if you are writing this or putting all this in pencil, if you have any corrections to do, you can easily erase and then you do it. But students don't do that. They would like to start with pen. Then if there's any mistake somewhere, they rub or they cancel and they lose marks. Now, you can also decide to do this table aside using your pencil in your answer booklet somewhere. Then when you are through, you cancel what you have done. And then you copy the right thing, maybe using your pen, and then you present it as your work. So we are asked to plot a graph of L in cm on the vertical axis against t squared on the horizontal axis. So we have to get rid of our table and then we try and see what we can do in plotting the graph. So we can try and get the table aside so that we can deal with the graph. So it says plot a graph of L. So they say a graph of L in centimeters on the vertical axis. And t squared in second squared on the horizontal axis. That's it. Now, this one, we are having an experiment and a simple harmonic motion. We need to get the period of a simple harmonic motion, L and T. The formula says period T is equal to 2 pi square root of L over G. That's the expression for period of a simple pendulum, 2 pi root of L over G. Since I'm going to plot L against T squared, then let me try and make L a subject. That will give me, I'll square both sides of the equation. So I have T squared equals 4 pi squared. Then if I square root of L over G this way, the square will go away with the square root sign. Then I'll have T squared equals 4 pi squared L over G. From here, I can try and make L the subject. Cross multiply. So I have T squared G equals 4 pi squared L. Then I'll divide through by 4 pi squared, so the L will stand alone. So I have T squared G over 4 pi squared is equal to 4 pi squared L over 4 pi squared. So we cancel out that and that and that. Got this and that. Then we have L is equal to T squared G over 4 pi squared. So let me split this a little bit for the purpose of our graph. I'll have L equals G over 4 pi squared T squared. Why? I want to compare what I have here with the equation of a straight line. The equation of a straight line says that, or is given as y is equal to mx plus c. So this that I've written here, I would compare it with y is equal to mx plus c. Y is equal to mx plus c. So I have L is equal to G over 4 pi squared L. That is what I have. Sorry, T squared. So we have L equals G on 4 pi squared times T squared. I want to compare this with the equation of a straight line, which says y is equal to mx plus c. How do we compare? I'm plotting L on the vertical axis, which is y-axis. So L goes with vertical axis, y-axis. Let me draw my axis. Now, in the physics practical work, the first thing you do after I've drawn the axis is label. If you only label the axis, you don't even draw the graph, you don't do anything at all, you'll be given 1 mark. That's if you label correctly. So I have L in centimeters on the vertical axis. Now they say it's be against T squared on the horizontal axis. So here, T squared goes with the x. So I go to T squared here in second squared. Now, how would this graph look like? So I'm doing all these as an aside though, before I even decide to go to the graph sheet and do the graph work there. I should know how the graph will look like before I even start working. Now, if I compare the gradient, and the gradient will be G on 4 pi squared. This is a positive value. So it tells me that the graph will give me a gradient with a positive value. Any graph, straight line graph, now the gradient is going to be positive, rises at this level. So we should expect that in our graph, the straight line should be rising. Now, will it pass through the origin? Will it have an intercept on the vertical axis or intercept on the horizontal axis? It will show us. If I check here, there's nothing here, so I could just say plus 0. So that I can compare this to that. So you can see that this C here represents the intercept, and it's 0. Meaning there will not be any intercept on the vertical or on the horizontal axis, but the graph will begin from the origin, 0. So the graph should look like this. So from the values in the table, if you should try and plot the graph, and we plot and plot well, we should have a graph moving from the origin like this. Straight line graph. Then we pick any 2 points on the graph. Maybe here, maybe there. Then we get a large right angle triangle, or a triangle this way. And that will help us to find the slope. So let's say the slope is S. So we find the slope. And we'll learn how to do that one to subsequently. Change in the L axis here over change in the T squared axis. And our slope will be a value which we will obtain. The aim of the experiment is to find the gravity, association to gravity, has a small g. And I'm going to show you how we can do that from what we are doing right now. So, assuming you found our slope, and what we have is S. Now the question goes ahead and says, calculate J equals 4 pi squared on S. So, 4 pi squared on S. 4 pi squared on S. or better still, 4 pi squared. So before we were doing comparison, we had L is equal to G over 4 pi squared times T squared. Then we compare this with Y is equal to mx plus C. We are saying that M represents the slope, which will come maybe S. So it means that the slope will be equivalent to G over 4 pi squared. The aim of the experiment is to find G. That means that G give you 4 pi squared times the slope. So in this experiment, when you find the slope and you multiply it by 4 pi squared, and your answer is not somewhere from 9.8 to 10 point, let's say 1, then the experiment has too much error. Because our aim is to find G. And G is either 9.8 or 10 ms minus 2. So this will give you an idea to know whether you did the experiment very well or you didn't do it well. This will happen if we plot L against T squared. Now, let's look at the other side. What if in our experiment we were rather supposed to plot a graph of T squared against L? A graph of T squared against L. So, a graph of T squared on the vertical axis and L on the horizontal axis. This one too, we still go back to the formula for the period of a simple pendulum, which says T is equal to 2 pi root of L on G. Because we want T squared, we will square both sides. To get T squared equals 4 pi, because this will be 2 squared, pi squared, then you have L over G squared. So the square, we take away the square root sign to give us T squared equals 4 pi squared. You have L on G. Good. It means that if I want to compare this with the equation of a straight line, then I'll get T squared equals 4 pi squared over G times L. So I have Y is equal to mx plus C. So when we compare, we plot T squared on the vertical axis. Then we plot L on the horizontal axis. See the gradient. 4 pi squared on G. Positive 1. So the graph will be an upward graph. See the intercept. There's nothing here. 0. So this also gives me a graph this way. We find the change in T squared on the change in L. And that will give us the slope, which we'll look at another time. Yes. Now here, the slope is equivalent to 4 pi squared on G. So we look at slope equivalent to 4 pi squared on G. So S equivalent to 4 pi squared on G. If I want J, I'll make it a subject. So J will give me 4 pi squared over the slope. So in this one too, when you find the slope, 4 pi squared, they are constants. So 4 pi squared, evaluate it, divide that by the value of your slope. You should be getting an answer from 9.8 to 10 or 10.1 maximum. If you don't get within those or that range, then it tells us that there was too much error in your experiment. Now, the last thing we're going to look at, or last but one thing, is the precautions that you're supposed to take as you go through the experiment. In every experiment, you are supposed to go through some precautions. Other than that, you are going to introduce too many or too much errors into the experiment. So you'll be asked to state precautions. State precautions. I wish you could get the opportunity to look at our lab. All the fans in the lab have been switched off. Why? In this experiment, you are going to oscillate the bulb. It must move under its own natural oscillation. It shouldn't be influenced by the wind. Other than that, it will go to what we call damping. Now, what's a damped oscillation? A damped oscillation is one that loses energy. Its amplitude will be decreasing with time because it loses energy due to air resistance. So we call it a damped oscillation. The amplitude of the oscillation will be decreasing with time because it is going to lose energy with time. It's going to lose energy with time. And that is what we call a damped oscillation. So let's look at precautions for this experiment. Precautions for this experiment. And it could be written for other simple pendulum experiments if and only if you go through those precautions. Precautions taken. Now, the question will say, state 2 precautions taken to ensure accurate results. You don't write the precautions as though you are telling the examiner what to do. Who took the experiment? You, the student. So what you did is what you write. Okay? So you write it as though you took that precaution. So I'll say, the bulb was displaced through a small angle. The bulb was displaced through a small angle. You could even have added to avoid elliptical oscillations. That's one precaution. The bulb was displaced through a small angle. A very important precaution. You put off the fans in the laboratory. Very important. You close some of the windows if the place is so windy to prevent the wind from interfering with the experiment. Other than that, the wind is going to damp the experiment. So, under these experiments where we're going to do oscillations, we don't allow the wind to just be blowing into the lab. We try as much as possible to take away wind interference. Now the next one, you don't write it if you don't do it, because if you don't do it and you write it, the examiner will find out. Okay. The timing of oscillations were repeated to avoid random errors. This one should be seen in your table, other than that you have exposed yourself. If we don't see T1, T2 before T mean in your table, showing us that the timing were repeated, then this precaution will not fetch you any mark. So before you write this precaution, make sure that your table shows that you took this precaution. The timing of the oscillations were repeated before you can write that there. Your table should show us that you have to repeat the timing. And that's very important so that you avoid random errors. And you should do that for every experiment where you are going to oscillate a body. Try to repeat the timing of oscillations to help you prevent what's called random errors. Let's pick one or two precautions, then we call it off there. So let's say parallax error was avoided when reading from the stopwatch and the meter rule. If you just write parallax error was avoided, you don't get a mark because somebody might talk about parallax error and be talking about something else. So anytime you speak about parallax error, the instruments involved should be mentioned in the precautions. Parallax error was avoided when reading from the meter rule. That should be okay. Parallax error was avoided when reading from the stopwatch. That should be okay. But don't just write parallax error was avoided. Now, in all the precautions I've written, I never use the word ensure. Ensure. Many students make this mistake. They say, I ensured that. I ensured this. If you say I ensured or I ensured that and that, and the examiner asks you how did you ensure? You will not be there to answer the examiner. So you don't use ensure in your precautions. It's very important. You don't use ensure in your precautions. Avoid the word ensure. The question might say, state two precautions taken to ensure accurate results. Fine, that's the question. But you don't use the word ensure in your precautions. You go ahead and state the precaution without the word ensure. The last part of our question is asked as a very important question. It says, state the effect of increasing the size of the bulb with time period. Wow. So, this is a pendulum bulb. And this is the size of my bulb. I could have another bulb. This is not the standard size of the bulb. No. There are other pendulum bulbs which could be smaller or bigger than this. So the question is, if someone uses a smaller bulb and another uses a bigger bulb, what will be the effect of increasing the size of the bulb on the period? Wow. So let me go back to our experiment. So the effect of increasing the size of the bulb on the period T of a simple pendulum. When we take the expression for period of a simple pendulum, it says T equals 2 pi root of L on G. That means that the period is dependent, is affected by the root of the length and gravity. That means that there's no mass in this expression. That means that the mass of the pendulum bob has no effect on the period of the pendulum. So, if the bob is big or small, it should not affect the period of the pendulum. That's what I'm trying to say. So, from this expression, there is no mass in it. So we say mass from this expression, the mass of the bulb has no effect on the period T. Rather, if there will be any effect on the period T, then it should be the length or the G. You go back to our table and check. As the lengths were decreasing, the timing of the oscillations were also decreasing. And hence, the periods were also decreasing. So you see that the period and the length are directly proportional. So as the length decreases, the period will also decrease. So you see that the period has got a direct influence on, or the length has got a direct influence on the period of motion. So that is it for this our practical section. And you have to take note of all that we have discussed here, not to repeat mistakes that most students repeat. Then you could be sure of scoring maximum marks in the practical work. So that will be it for today's practical session. I hope to come your way another time where we will take time and look at going into drawing the graph. Then we will look at other experiments too on simple pendulum that are not just as simple as this one, but they are a little bit involving. Till then, it's the Joy Learning Television Channel, Senior High School Hour. We hope to come your way another time with an exciting practical lesson. And Kpabi Albert is my name. And then we say, Joy Learning, keep learning. It's bye for now.
Subscribe to our YouTube channel, Joy Learning TV.